Hey, students. Oh, welcome back. You know what? We're talking today a little bit about slope, finding slope. But this time we're finding slope from a graph and also from a table. Okay, let's practice that a little bit. Now, slope is also my unit rate. It's also my rate of change. And in my equation, it's my coefficient. So my slope is really important to find, and I want it to be accurate. So let's talk about how to find a slope when you're looking at a graph. Now, the slope is really the change in values. That's really what it is as it changes along. And that's what the rate is. How much is it changing as the information moves along? That's your rate. That's your unit rate. Also, it is your slope. Let's go ahead and find it. So one thing you want to do is you want to grab, put a point where the intersection is. Just find an intersectional line like that right there. Like, hold on, turn on the pen, ding, pen on. Here we go. Now, like right here, not an intersection. Right here, not an intersection. Right here is an intersection. So find nice, good intersections that you know exactly where those are because you want to move between them. So here's a point and here's a point. Now I want to travel from one point to the next. That's how I want to do it. And I want to follow the grid lines when I'm doing it, but I want to keep track of it. So as I start at the top line here, I travel down 3, which is going to be dropping 3, negative 3, and I'm going forward 1. All right, and if I want to, if I pick a couple of different dots, like this dot up here and this dot way down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, that drops 9 and goes forward 1, 2, positive 3. Now the thing is, when you're finding slope, it is a ratio, okay, just like rate of change and all those things. Those are all things. It's a ratio, but it's your ratio of change in y over change in x. All right, my change in y for my purple one is it changes negative 3 over 1. And then the other, like darker purple one, it changes negative 9 over 3. Both of these equal the same thing. Both of these equal negative 3, which tells me a couple things. It tells me that my slope is negative, which means it is decreasing. And it just tells me it's 3. It changes 3 for every 1, which is really good, which is true. Notice this. For every 1, it changes 3. Totally true. It's the unit rate. So the slope is right here is negative 3, which is awesome. Let's do it on this guy. Let's find the slope. The slope. Let's find any 2 points. I'll grab this point, and I'll grab this point. All right. So 1, 2, it travels forward 2 and goes 1, 2, 3, 4, 5, 6. It goes up 6. Now it's change in y over change in x. And it looks like my y is 6 and my x is 2, which is positive 3 because it's increasing. Now I've had some students go before, like, how about if I go from start at this dot and go back down? So 1, 2, 3, 4, 5, 6, which is negative 6, and then I go backwards, 1, 2, which is negative 2. You can do that, but then you end up, like, let's just take a look at it. Then you have negative 6 over negative 2, and negative 6 over negative 2 is also 3. So you can totally do that. Just pay attention to your negatives. But this is my slope. Now your slope won't always be like a nice whole number. Sometimes it'll be like a fractional amount, which I think happens in these tables. So let's look at these tables. Now the graph was nice because you're going from one point to the other, but keep in mind on this table, these are points. These are all points, and we're going from one point to the other. So let's go from 2 to 4. Now, when you go 2 to 4, I'm noticing that to go from 2 to 4 is positive 2, and to go from 2 to 5 is positive 3. So again, I'm trying to find my y over x. My y is 3, and my x is 2, so it looks like it's 3 halves. Let's say I wanted to jump from here to here. Well, that changes by positive 4, and from negative 1 to 5, it changes. So if you're at negative 1, you go up to 5, you change 6. So it changes 6 over 4. Which is actually equal to 3 over 2. Now, when you're doing a slope or something, when you're doing, you can leave it as a ratio like this, 3 over 2. In fact, that is preferred, so you want to get in the habit of doing that. Some students want to do 1.5, which you can do, but 3 halves is super duper accurate. Let's try it on this table one more time. I'm going to jump from here to here. Woo! So that changes positive 2. And then from 4 to 3, look at that. That's going down, so that's going to be negative, and it changes negative 1. Now, I always do y over x first, just because I want to make sure I build this the right way, because it's negative 1 over 2, which is negative half, right? If I did it the other way, negative 2 over 1, that means it's negative 2, which is totally wrong. So be careful of your ratio. Now let's say I do like a little jump right here, like 5 over 6, which is changing by 1, and 2.5 over 2, which is going down 0.5. Look what this is. This is negative 0.5 over 1, which is equal to negative 0.5, which is half. See, you still find it. It's there. Awesome. And in an equation, your slope is just your coefficient. There it is. And this guy, you just got to grab the negative for it, and there it is. Nice. Oh, I love it. You guys did a good job. Now, I'm going to take, you can be done listening if you want, if you haven't stopped already. Hey, listen in real quick. Let's find the y-intercept, because if you find the slope, that rate of change, and you find the y-intercept, you can build an equation real quickly. So this guy, the y-intercept is 6, because it's where it crosses the y-axis. So just remember in your equation, it's positive 6. This one, it is also positive 6. It's right there. It's where it crosses the y-axis. The y-intercept is where x is 0, so that's going to be this guy right here. On table 2, we don't have where x is 0, but I can find it if I just follow the pattern and just keep going, and it looks like it drops. Oh, it's increasing 1 each time, so actually it's 5. And the y-intercept is right there, and the y-intercept is positive 20. So once you have your y-intercept and once you have how much it's changing, you can build your equation. All right, keep practicing stuff. You'll get amazing at it. It doesn't stay hard if you keep at it. All right, later, Gator. I'm going to go lick a frog and see if it